Hello, everybody, and welcome to another edition of Cloud Tool Time, brought to you by the Eclipse Cloud DevTools working group. My name is Brian King. I am the community manager for Eclipse Cloud DevTools, and I'm delighted today to have as our speaker Marc Nuri. So a little bit about Marc. He's an open source, of course, developer and enthusiast. He's currently working as a senior engineer for Red Hat in the developer tools team, focusing on Java. And he's leading the development efforts of Eclipse JKube, and he's part of the core maintainer team for the Fabricate Kubernetes client. So Marc today is talking about bringing together some of my favorite projects right now. So if you haven't checked out Quarkus, I urge you to do so. It describes itself, I think, very well as supersonic subatomic Java. And Marc's going to talk about how to deploy a Quarkus application into Kubernetes with JKube. And JKube is, of course, one of the ECD tools projects that we're overseeing in the working group. So over to you, Marc. Take it away. Thank you.
Okay, so thank you, Brian, for the introduction. As Brian said, I'm Marc. I'm a software engineer working for Red Hat, and I'm currently working on two open source projects, the Fabricate Kubernetes client and the Eclipse JKube, that we will see today. So basically the agenda for today, or the plan for today, is to see how JKube works, and by bootstrapping a Quarkus application, and then walking you through on how to deploy this application first into a Kubernetes cluster. I will use my local Minikube cluster, and then into an OpenShift cluster. So I will start first by describing a little bit what JKube is, and then we'll walk into the demo right away. So if you have any questions or something, just type them in the chat, and I will try to answer them while we are going through the presentation. Okay, so basically and very quickly, what JKube is a set of tools and plugins that will help you generate container images for your Java application, and then generate cluster configuration manifests and deploy them into Kubernetes or OpenShift cluster. Currently, the project consists of three parts, or two parts. Like there's this standalone Java API, which is a library we call Kit, and then we have two Maven plugins that are built on top of this library. The first one is the Kubernetes Maven plugin, and this is a Maven plugin that you should be using when you want to generate container images and deploy them in a Kubernetes cluster. So it will use Docker as standard to create your images, and then it will generate vanilla Kubernetes resources to deploy them into Kubernetes. On top of this, we built the OpenShift Maven plugin, which is a more specialized way to deploy to OpenShift. So it will actually use S2I to build the images, and then it will create OpenShift specific cluster configuration manifests, such as deployment configs or routes, etc. I'm going to walk you through this very, very quickly, but we will see it later on in depth. There are three ways to configure the JKube, or the Kubernetes Maven plugin, or OpenShift Maven plugin. The first way is no configuration at all. So the way JKube works, it analyzes your project, and then it infers all of the configuration for you. So at JKube, we have a set of opinionated defaults that is what we consider best for the framework your application is using, and the cluster you are targeting, etc. Of course, most applications require some special tuning, and obviously all of these opinionated defaults won't be enough for you. So we have two ways to improve this configuration. The first one is by using XML configuration. So the same as you would configure any other Maven plugin, you can provide XML configurations. And the other one is by using resource fragments. So what you can provide is a partial resource or YAML configuration for your cluster. Then JKube will pick this resource. It will merge it with the ones it generates by default. So again, we will see this when we start the demo. Okay, so from a developer's perspective, the Kubernetes Maven plugin, what it provides is a set of extra Maven goals. So if you've used Maven, which I'm quite sure most of you will have, whenever you package your application, you would use the package goal or the install goal, and this is where you would generate the artifact for your application. But then now you have the challenge to deploy this application into a Kubernetes or an OpenShift cluster. So what you need is to create a container image. So for that, JKube or the Kubernetes Maven plugin provides the build and the push goal. The build will create the container image, and the push will push this image to a shared registry. And then there is the resource goal that will generate the cluster configuration manifests, and the apply goal that will take these manifests and apply them into your cluster. On top of this, there are a set of additional goals that are intended for development purposes and to help you as a developer. So you have the log goal, which will actually retrieve the logs from your container or the container running in your pod. The debug goal, which will allow you to debug your application on the cluster. The watch goal that will be monitoring changes in your local files and will automatically redeploy your application. And the undeploy goal, which will do the opposite of the apply. So it will remove any resources that were created in the cluster. So as I was telling you, the plan for today is to bootstrap a Quarkus application. And first, I will be deploying this one into a Kubernetes cluster. So the first and the easiest way to bootstrap the application is to go into this starter page, the quo.quarkus.io. And just to keep it simple, I'm just going to select this module. Okay, and I'm going to download the application. So we're going to zip this to a temporary directory. And I'm going to open this in my IDE. Okay, so the Maven project was detected and was loaded. And the first thing that you will notice whenever you bootstrap the Quarkus application from the site is that it comes with a set of boilerplate Docker files. So these files here, and this is what Quarkus provides out of the box for you to deploy the application and to generate the images. JKube doesn't require this, so we will be automatically creating the image for you. So the first thing that I'm going to do is I'm going to delete this, which is not necessary. I'm also going to delete this test because I'm going to tamper with the provided code. You usually wouldn't delete the tests, but just to speed up things, I'm going to delete this, okay? And I'm going to set up my environment. So Quarkus requires Java 11. And as I told you, the first part of the demo, I will be showing it in my Minikube cluster. If we come back to this slide, I told you that we had the build and push goals. So in order to make things faster, I'm going to share my Docker registry running in Kubernetes. So I can do this for Minikube by doing this. So this will avoid the extra step of pushing the image each time and will make things faster for now. Okay, so that would be it in terms of the environment. And now I'm going to add the Kubernetes Maven plugin to the project. And that's it. That's the initial part, the first part of the configuration. We have just made our application cloud native. So as usual, we are going to package our application. So far, this is the same that you would do in any regular Maven project, and this will create these two artifacts. So we would be at this step here. Next, I'm going to build the image. So the image was built, and if I check the current image, I see that we just created this image here. As I told you, by default, OpenShift JKube provides a set of opinionated defaults. In this case, the name of the image is part of the artifact ID and the group. The same will happen with the rest of the resources that we create for Kubernetes. They will all be named code with Quarkus. We will see this later. If we want to check what JKube did here, it's not necessary, but it created a Docker file for you, or an intermediate Docker file, and this is what it was used in order to generate the image. Next, we are going to generate the resources for our cluster, the configuration manifests. So that's it, and we can check this here. These are generated here. Again, this should remain transparent for you. Usually, you wouldn't be checking this, okay? But as you can see, we created a deployment. It shows the image we just generated. It selected the ports and so on. It also generated a service for us. Okay, so now let me show you. Okay, so this is a dashboard for my local Minikube cluster, and I'm going to filter the resources. So the next thing I'm going to do is I'm going to apply. We come back to this slide. I'm going to apply these YAML files that we just saw. So eventually, once they get applied, we can see how the resources were created in my cluster. Of course, right now, this created a cluster IP service, and there is no way to access this application because it's inside Minikube. What I can show you for now is the log. So if we want to check the log for the running container, we are able to retrieve this log, and we can see that the application started and it's running okay. Okay, so far, just by adding the plugin here, we were able to deploy the application in Kubernetes. The next thing I'm going to do is I'm going to expose the service port as a node port so that we can actually access the application. So just by adding this property, as I told you, there are several ways to configure JKube or to override the defaults. One of them is by providing maven properties. We could also configure this in the plugin section by using configuration elements. But now, if I reapply my resources, this should change to a node port. Okay, so we changed, and we can actually access the application. In fact, there is a resource here, so we should be able to check this endpoint. Yeah, it's working okay. So, well, one other thing that I wanted to tell you is that you are seeing me running all of the goals separately. If you were to integrate this in a pipeline, you would probably don't do this. And I'm going to do this because for education purposes, it makes more sense. But what you could obviously do is configure an execution like Eclipse, and you would actually combine. You could actually combine all of these goals that we saw and maybe bind them to an execution phase. So basically, if you did now this, it would be the same as building, creating the resources, and applying them. Obviously, since the resources haven't changed, nothing is happening, but that's it. Okay. Anyway, I'm not going to use this now because I prefer to show it step by step. So far, we were able to create a node port, but obviously this is not the most recommended way to expose a service in Minikube. You would usually use an ingress in Kubernetes. You would use an ingress, or if you were using OpenShift, you will use a route. So since I'm using Minikube, I'm going to enable ingresses. You would do this by executing this command. I have already enabled them, so we can skip that part. And I'm going to add an ingress. Okay, so one second. Okay, so maybe, I don't know if you know this service, but what it basically does, it creates DNS for your local IPs, and it's quite useful for your local environment and tests like this. So what I'm going to do is I'm going to create an ingress with this base domain. So in order for JKube to create an ingress, we need to provide these two flags. The first one will actually tell it to create the ingress, and this one will be used to configure the base domain. The resulting domain will be a combination of the artifact ID and the domain we provided here. So if we recreate the configurations, so here we should, okay. Now we see that JKube created an additional configuration for us. In this case, an ingress, and as I was telling you, the host will be the combination of the artifact ID and the host that we provided. If we reapply this to the cluster, we should see that an ingress eventually appears here. Okay, so you can see the ingress is here, and if we check the domain, we are able to access it. Again, we do the hello restz, same as before. Okay, so just to recap, for those of you who might have get lost, we were just able to deploy the Quarkus application just by adding the plugin configuration, and then we were able to, on top of that, generate an ingress just by providing two configurations in the shape of a maven property. So my opinion is pretty cool. Next I'm going to do is I'm going to generate a resource. So an extra endpoint so we can actually check more stuff. Okay, so probably when you are developing microservices or any other stuff, you expect the application to interact with other elements of Kubernetes, probably other applications and so on. Since I don't want to make things very complicated, I'm just going to show you how to create or how to use environment variables and config maps and so on. So, but we will also see how the application interacts with other components of Kubernetes. So in this case, the first thing I'm going to do is create an environment property, environment variable. So I will call it greeting, and I will add a default. Okay, so now we can create an endpoint. Produces. Let's keep things really simple. And I'm also going to add something for later. So I'm going to add this. So default value, false. Okay, so if we have this variable set, we will throw an exception. Okay, so if we were to run this in a local environment, everything should be working fine. So if I go to the test endpoint we just created, we see the hello world. Okay, but as I was saying, you probably want to retrieve this configuration from somewhere else. The first thing I'm going to do is I'm going to add a very simple environment variable to the deployment. So using XML configuration, we have the resources configuration here, and we can add environment variable. So I had this greeting. I will change this with hello ECD. So if I need to recreate the image because we changed the code. Okay, but if I create now the resources, the deployment should now contain this environment variable. Yeah, here it is. So if we reapply this to the cluster, application is restarting. So if we open this, instead of seeing hello world, we should be seeing hello ECD. And here it is, okay? So what are the advantages of doing this? If we define some property here, hello ECD, we can actually, so if we change this via the command line, we can, via the command line, we can override this setting. So probably you're starting to think that this might be useful in case if you want to provide Maven profiles or things that you want to tune like right away. So as soon as it redeploys, now we should be able to see hello people here, right? So probably you're starting to understand what are the advantages of this, okay? As I told you, there were also another way to configure things was by using resource fragments. So the next thing I'm going to do is I'm going to provide another variable, but in this case, using a config map, I will define the config map in the XML configuration. So we have this throw exception. Okay, so I define the config map here, but what I want is to be able to retrieve this config map in my deployment. So for that, what I'm going to do is I'm going to provide a fragment for deployments. So you need to add your fragments into the JKube directory in the source main JKube, and I will create a deployment here. Okay, I have everything here. So basically what I'm providing here is a partial resource. I'm adding to the first of the containers the environment variable, and this environment variable is going to come from a config map which is named like this. So this name must match the one that we have in the XML configuration. I also want you to notice that we can actually provide Maven variables here, and Maven will filter this when it's generating the resources. So that's, again, really powerful when you want to provide different profiles or override these settings at runtime, or maybe for one of your pipelines, or depending on the environment and so on. Also, for consistency reasons, I'm naming it as the artifact ID, so it will also appear in the dashboard. Okay, so if I generate the resources, an additional config map should be visible here. Yeah, so here it is, the config map that was generated via the XML configuration. And if now I apply this to the cluster, okay, the application is redeploying again, and we should be able to check the endpoint. Okay, so probably some of you spotted what's happening here. I introduced this error on purpose. Maybe some of you already know what it is, but for those of you who don't, now it would be the real use case for the debug goal. So we saw that the application was working locally, but now we deployed it into our Kubernetes cluster, and apparently the integration with other components, in this case the config map, is not working as expected. So you would usually be thinking, how am I going to debug this? So this is one of the main or strong features of JKube. What I'm going to do is I'm going to invoke the debug goal. And what's actually going to happen is that JKube will restart the pod, or will with a debug flag set to true. So since our base image is specially tuned for JKube, it will actually restart the Java application in debug mode. If we check here, we now see the message. Now you can start a remote debug session by using localhost and the debug port 5005. So I can now configure a remote debug session in my IDE. And basically, these settings should match the ones here. So these are the defaults, the 5005 port. So now I should be able to connect. I'm connected. And since we have the exception in this endpoint, I'm going to add a breakpoint here. So you see that the breakpoint was submitted. When I now restart or refresh my browser, you see that my IDE stopped in the breakpoint, and I can actually go through, oh, throw exception is true. So I'm actually getting this exception. If I refresh, I would be able to change this value, see what happens. And yeah, now the application is working again. So since I replaced the value in the running application, now it's not going to fail. Of course, if I redeploy, it will fail again. So eventually, when this redeploys, it should fail. Yeah, terminal server error. Okay, so now we know where the error was. There was this throw exception. This value should be false. So if we repeat, the exception should be gone. It's not redeploying. I'm going to trigger the redeploy manually, but now it's gone. Okay, so you saw the real power of being able to debug in the cluster. Locally, application works, but whenever you deploy something in the cluster, it starts interacting with different components, and you have no clue of what's happening unless you have strong logging and so on. But really powerful. Let me check my notes. So, okay. So if we go back to the slide, as I said in the beginning, in order to speed things up, I was going to skip the push goal. Okay. So now let's try to push the image to Docker Hub. It should be as easy as running this goal. So when we push, okay, we get an error. The error here is because I'm trying to push this image, and I obviously don't have permissions for this repository. What I'm going to do is I'm going to use this repo, which I usually use for my tests. So in order to push there, I have already pushed here. So what I'm going to do is I'm going to overwrite the name of my image, and I can do this by providing another JKube configuration. In this case, Marc Nuri repo for tests. So now it's pushing. There's no error here. And if we check the repository, yeah, we see that the application, the image was updated a few seconds ago. If we check the layers, we should see that this match with the ones in the Docker file. Yeah. Again, one of the cool features of JKube is the flexibility. So the default is that JKube, if it detects Docker, it will work with Docker, and same as if it detected a Kubernetes cluster and so on. So it detects some stuff and it will use that stuff by default. It also detected that the application was a Quarkus application, so it's running the Quarkus specific generator. All of these are things that you can override, as you saw. One of the other things that you can override is the way you build the image. So for this environment, we also support Jeep. So if you want to build with Jeep, it would be as simple as changing the build strategy to Jeep, just another configuration. If we do this, the build method will change. So now you see that we are using Jeep, and same for the push, it's using Jeep. So this means that you don't need any tools such as Docker in your environment, no external tools. Just by having Maven, you can complete everything. So if I check the image again, this should have been replaced. Yeah, and if you see, the layers are now compatible with the Jeep build. Okay, yes. So just to conclude the Kubernetes part, I'm going to show the last of our goals, or the undeployed goal. And what this basically does is clean up the cluster. So we created a lot of resources during this demo. So what I'm going to do is the undeploy. And whenever the goal completes, we should see that all of the resources are deleted. As you can see, everything was deleted. Okay, so I don't know. I don't see any questions so far. So, well, greetings to everyone. Now I'm going to continue with the demo, but with OpenShift. So
yeah, I agree. Yeah.
Okay, Marc, we'll continue. Go ahead. Yep.
Okay, so for the next part, I'm going to use. Probably you don't have access to an OpenShift cluster. So what I'm going to use is this developer sandbox that Red Hat provides. This will provide you with a test OpenShift cluster that's lasts for 14 days or so on, but you can renew it. Obviously, the resources here are not that great, but okay. So the first thing I'm going to do is I'm going to log in my local environment, if it helps. Okay, so and I'm going to choose the same project that I have here, this one. Okay, so in order to switch from Kubernetes to to OpenShift, we just need to do this. And that's it. Well, I'm also going to remove this ingress because the OpenShift Maven plugin will create a route, which is more appropriate for OpenShift. But this is all I changed to be able to do the same with OpenShift or with a more specialized OpenShift configuration. Now, let me clean everything up. So let me start by building the container image, just as before, but now the goals, instead of be prefixed with KHS, you prefix them with OC. I'm going to start with the build. So we detected the OpenShift cluster, same generator Quarkus, and so on. And this, since we detected the OpenShift cluster, we are going to use an S2I binary build by default. So if we go into our cluster, we can see that the build has started here a few seconds ago. We should be able to go here, and we can actually see that the build logs are exactly the same as the ones that we show down here. Obviously, this is an evaluation cluster, and the resources here are not great, so it will take a while. I don't know if there are any other questions around, not so far. Okay, so basically now what just happened is that a pod was bootstrapped in the OpenShift cluster, and this pod received the artifacts that we generated, and the Docker build started inside the cluster. So this is actually happening there.
Mark, in the meantime, I've got a couple of questions if you would like.
Yes. Yes, Brian?
Sorry, Brian just had to go on mute there for a second, but I can ask as well. Unless, Brian, are you back now?
Yeah. Apologies about that. Yeah, so it's my understanding that a lot of the functionality you described is available via Quarkus extensions. So what's the advantage of using JKube instead of that?
Yeah, that's true. So feature-wise, I'm not really sure that, or not sure if the Quarkus extension provides all of the features that I showed today. Maybe it does, and eventually it will for sure. If it doesn't, probably it does already. So one of the main advantages is that it probably in your team, and especially now since it's the early days of Quarkus, you are managing several projects, some of them in Quarkus, some of them are built with Spring, maybe some others with Vertex or any other technologies. So the key feature for JKube, or why you should use JKube in this situation, is because it will be consistent. So you will be using the same tools to deploy your applications into Kubernetes or OpenShift or whatever, and it will be everything the same for all of the frameworks that you're using. So if you're using Spring, you will be using the same that what you are using here in the Quarkus example. So the first one is obviously consistency. The second is that, well, it's good to have a choice. Also, I'm not sure about the Quarkus extensions, but with JKube, there are no external dependencies. So just by having Maven, you are ready to go. And that's it. There are many. I don't know. Just what I recommend is that try it, and if it's good for your team or you find it suitable for your team, just go ahead. Probably there's also some people that come. Maybe this is not as known, but JKube is not a new project. It's the update of the Fabricate Maven plugin. So if you are coming from the Fabricate Maven plugin, the configurations and the way of work is the same. So you probably already know how to work with that. So again, it's another of the advantages. So anyway,
Just I'll ask this other question before you jump back in there. So we have a question come in from Carlos. He says, I've seen that when Marc switched to OpenShift, the application logs came from the OpenShift server itself. Was the behavior the same with JKube plugin for Kubernetes? Maybe I missed something.
So this is, maybe it wasn't clear enough. when I run the build using the Kubernetes Maven plugin, the build is happening in my machine. So I'm actually building inside. So Docker is running in my machine or Jeep or whatever, and this is happening here. When I did the same for OpenShift, what happened is that the build was spinned up in a pod inside the OpenShift cluster. So nothing happened in my machine. So that's why the logs are retrieved in order to give you information of what's actually happening. If, I don't know, maybe if I go back here to the previous logs, yeah, these logs that we are seeing here from Jeep and so on, these are actually things that are happening here in my local laptop, not in the remote environment. Here, on the other hand, these are logs that are retrieved from a pod or a container inside a pod in OpenShift. Hope that's clear enough. So now, actually, I mean, if I check my Docker images here, maybe this is clear enough. This is the image that I built before, but it has nothing to do with the image that was built here. This is in the OpenShift image registry, and if you see, it has even a different name and so on. Okay. Anyway, just going back to the presentation, and I'm going to be very quick. Just we created the image, and now if we want to create the resources, we use the OC resource goal, and we should be able to check that JKube generates, same as before in this directory, some OpenShift resources. So it generates a deployment config instead of a deployment. Same as before with the environment variables, with the configuration for the config map, the service, the config map, and in addition, it creates an OpenShift route. So instead of the ingress, I'm going to use this route, and you will see when I deploy. So now if I apply the resources and I go to my topology here, okay, you see that the resources were applied, and now the application is spinning up. So the pod was deployed, and it should be running in a second. It's taking a while. Okay, it's running. So since we created the route, or JKube created the route for us, we are able to check this. You should also be able, if you were to check this URL in your machine, you should be able to reach my application right now. Okay. So same as before, the endpoint is here. And for debug purposes, it's exactly the same. So we run the debug goal. Obviously, now it will take a little bit longer since there is you need to connect to a remote environment, and also there are not the resources for this OpenShift cluster are not that good. So the pod has restarted in debug mode, and we should be able to connect there. So eventually the message, okay, we are connected, and the breakpoint was just submitted. So if I check here again, my ID should stop, as you can see. Again, it's a little bit slower, but you can see that we are actually grabbing the variable, the values, and the stack from the remote pod. So quite cool. So yeah. Okay. So just to end it, I'm going to run the undeploy goal again. And we should remain with a clean cluster. So yeah, everything is clean, and yeah. So basically, this was what I wanted to present you today. I don't know if there are more questions, but now is the time to ask them. So
yeah, there's a conversation happening in the chat there about, local versus server resources during build and so on. And I think Rohan has answered it somewhat, and Carlos is dropping a comment in there as well. I don't know if you want to follow up on that, but I have another question. Are you planning on supporting Gradle projects as well?
Yeah, well, this is something that we were planning just from the beginning, but we haven't been able to deliver it yet. We really want to deliver this, and we're going to start to work on the Gradle plugins. I don't know, maybe this week or next week. So yeah, we are planning on delivering this as soon as possible. So that's something we really want. Okay, I'm checking here the conversation. So.
Yeah, have a look. See if there's anything else you want to add there.
Well, I think Rohan is already answering, but yeah, you can. I'm using the OpenShift Maven plugin with the OpenShift cluster. You can use the Kubernetes Maven plugin. As I said, the main difference is that OpenShift uses a special OpenShift or creates special OpenShift resources, but I don't know, OpenShift is just Kubernetes. So if you are happy using the Kubernetes Maven plugin, you can go ahead and use that. Same for the build strategies. For now, the recommended build strategy in OpenShift is S2I, but I think that those things are changing. I'm not an expert in OpenShift, so I wouldn't be able to say that, but probably in the future things change. So in the end, what we want in JKube is to provide this flexibility. So if you want to use Jeep, use Jeep or Docker or Podman or build packs or whatever. But what we really want is to be this umbrella plugin where you put JKube and then you just configure a few things and you are able to depending on the environment or depending on the target application or whatever, you are able to change things quickly and by using simple configurations. I don't know if there's anything else there.
Yeah, a new question just came in. Is there a plugin for this to work with Eclipse IDE?
Well, I mean, this will work with any IDE because it was just Maven. So I'm not sure if this is the question, or basically what one of the things that we want to accomplish too is to provide autocomplete. So you saw me that I was creating these XML configurations, and we already have an issue for that, which is I don't know. We want to provide it for all of the IDs. I don't know if there is maybe by providing an XML schema or something like that, we can accomplish that. We are still discussing that. But again, one of the other things that I wanted to tell you is that please get involved. This is a community project. It's hosted by the Eclipse Foundation. So what we really want is for people to get involved in the project, to participate in discussions. We hold, I think that there's people here from Barcelona that have already joined some of our meetings or participated or contributed to the project. So any contribution you can make or just participate in our social networks or the Gitter channel and so on, everything is welcome. So that's one of the things that
is there like a one-stop shop page where people can go to find out how to get involved?
Well, I mean, you can, sorry. So if you go to our homepage, we have this for contributing. These are instructions in case you want to contribute code or documentation or things like that. But we have this community page. So here, how to get support, how to chat with us, Twitter. We have a YouTube channel where we post our sprint reviews, Stack Overflow tags, mailing lists. So these are the sprint plannings, which are also held publicly. So you are free to join if you want. Anything is really welcome. So
yeah, and the URL that Rohan kindly put in the chat is www.eclipse.org/jkube/community. Not seeing any new questions come in. Does anybody have any last questions? Okay. Thank you very much, Mark. Before that was super informative. And before we finish, I just want to do a couple of housekeeping announcements. There's going to be a few links posted momentarily related to these, so keep an eye out for them. But the next Cloud Tool Time is on March the 9th. And the topic for that one is web-based modeling tools with emf.cloud. The speaker will be Maximilian Kegel from Eclipse Source. So watch out for that one again, March the 9th. We'll also be posting a link where you can fill out a form if you want to propose your own topic or if you want to speak yourself on Cloud Tool Time. So we're always looking for new content, for ideas. We have a good set of speakers lined up for the next couple of months, but we want to really extend that and provide more value to the community. Just a reminder also to click the green button below the video to give us feedback on this session, whether that's good or bad. We need to hear your feedback to try to make these events better. Again, that's the green button. I think it says, help us improve by completing the post-event survey. It should be there now, so please click on that now. And that's it. That's pretty much a wrap. Again, I want to say a huge thank you to you all for attending. Thanks for coming along. And thank you again, Mark. And best of luck with the JKube project moving forward.
Okay, thank you. Thank you, Brian. Thank you, everyone, for coming.